Hi, Assalamualaikum everyone. How are you guys doing? So welcome to CHE505. I'm Nur Hashimi Rahmat. I'll be the lecturer for you guys for this semester. So hope you guys enjoy with my video. Um, so anything if you guys don't understand, you can just private message me through Google Classroom or WhatsApp group. So for this first lecture video, I'm going to proceed with topic 1 on chemical catalytic reaction. I'm going to start with the subtopic of here, the catalyst first. Okay, so in this subtopic of catalyst, we're going to see what's the function of catalyst, what are the types of catalysts, and hopefully after the end of this subtopic of catalysts, you'll be able to explain the definition of catalysts, the functions, and the different types of catalysts. So let's get started. Okay, so the course learning outcome. It says here by the end of this topic, you should be able to explain the steps in catalytic reactions. You'll be able to write the mechanism and the chemical kinetics. Hopefully that you'll be able to describe the rate limiting step, and hopefully also you'll be able to describe the meaning of the Langmuir-Hinshelwood kinetic mechanism. So let's go to the first subtopic, which is catalyst. By definition, catalyst is actually a substance, and this substance actually would affect the rate of a reaction, but it looks like the catalyst does not change, and it only affects the rate of the reaction, but it doesn't change the process itself. And the catalyst usually will use different paths actually for a mechanism for one reaction. So meaning that there will be different if one reaction first that it used without catalyst, the mechanism would be different. But once you employ a catalyst, the mechanism is going to be different as well. So the catalyst also would affect yield and the selectivity. So, but it only affect the rate of reaction, but it doesn't really affect the equilibrium of one reaction. So basically, this slide it defines what is catalyst, and basically it defines what is the purpose of the catalyst. Okay, there are catalysts that actually would speed up the reaction. So we call this as positive catalysts. Okay, but there are also catalysts that would actually slow down the reaction. So this we call this as inhibitors, or other names is negative catalysts. So apart from catalysts, there is a substance in which that if this substance can increase further the activity of catalyst, let's say the catalyst are already speed up one reaction, but if it's find out that if we combine one catalyst and another substance, and it looks like the activity of catalyst is further accelerated, so we call that substance as promoters. All right, and but if there is a substance which actually deactivate the catalyst, so we call that as the poison catalyst poisons. Okay. Um, We're looking at the activation energy. If looking at the blue one, if let's say the blue one is the reaction without catalyst, and the red one is the reaction with catalyst. So um, this amount, we call that as the activation energy. So if the reaction without catalyst, we can see that the activation energy has a higher amount compared to the reaction with catalyst. The reaction with catalyst, it has smaller activation energy. So meaning that if one reaction employs a catalyst, the reaction would go faster, and in terms of cost, of course, the lower activation energy would cost less compared to the one without catalyst. Okay, basically what happened if one catalyst uh, involved in a reaction. So first that the catalyst would take part in the reaction in which that it will interact with a reactant or the molecules inside of the reaction. So once it reacts with the reactant, it will actually alter the rates of reaction, in which that maybe it will increase the rate of reactions. In some situations, there are also instead of the main reaction, it would actually accelerate the undesired reaction. So in some situations also, the undesired reactions is also suppressed. So it actually depends on what type of the catalyst. And then once the reaction almost finished, the reaction may return to its original form, but sometimes because if the catalyst has been used over and over again, so it would actually shorten the lifespan of the catalyst, and gradually the catalyst will be deactivated. So this is example shapes and types of catalysts. You can see that this is the monolith type. Okay, monolith type. This one is the cylindrical type. This one is the spherical type. So the types of catalysts is actually you can just find it on the internet because the field of catalysis is matured already, so you can find the information on the catalyst on the internet instead of apart from this slide only. Okay, for this slide is just to show you an example. For example, that we have this what you call this as reactor here. Let's say that we have tubular reactor, and inside this reactor we have this small catalyst, and this small catalyst it made into a bed of catalyst. Ini kita panggil a bed of catalyst. Jadi let's say that we take one small catalyst here, and this one small catalyst here is represented with this figure, in which katalah this sphere catalyst, it actually contains of the pores, adalah surface area over here, And kalau kita bentangkan the catalyst ni, the catalyst, we call it as catalyst palettes ni. So this is, kata kita bentangkan dia. So kita boleh nampak, kita boleh bayangkan that this is the catalyst palette surface. So on this surface is actually there will be reaction happens. Okay, the reaction will happens on this catalyst surface. Alright, this is more on the definition of catalysis. So basically, catalysis is the process to change rate of chemical reaction due to participation of catalyst. Or other definition of catalysis is the occurrence or the study and the use of catalyst in catalytic process.